Hi, this is Jeremy Solentine with Temperature Systems. Today we're going to talk about the PWM ECM motors, or variable constant torque motors. Alright, so one of the first things you do want to do troubleshooting the motor is make sure you've got high voltage to the motor. So we unplug the plug with power, the white and black wires coming over to the motor, and then we want to take a voltage reading on those wires. So now we know that we've got 120 volts to the motor itself. We'll plug the motor back in. Rest of our troubleshooting we'll do from up here in the harness. So now we've jumpered R to G to make a call for the circuit board to turn the blower motor on. And as you can see, we've disconnected the control wires running over to the blower motor. It's the yellow and brown that we're going to pay attention to. We're looking for voltage DC voltage on the meters, and we're going to compare these two meters to see an example of how different meters may read the same signal differently. So we'll start off with the fluke over here, and again, yellow and brown. Now as you look in here, those pins are extremely delicate. You can't force your meter leads in there, or you're going to cause an intermittent connection. You want to be very gentle and just touch them in there. Or the preference would be, if you've got the real small leads for your meters, to actually come in the back side. However, the larger pins, larger probes are not going to fit in there real well. So with these we're going to be very gentle. As you can see, we are set for volts DC on this meter. That'll light up a little bit better. We're going to set our range for a couple of volts on there, and we're going to gently touch our meter lead into those pins, and we can see on this meter we're reading approximately 8.4 volts. The positive or negative doesn't matter, that's just your meter leads being switched around. As compared to our fluke meter right here, which will give us a different voltage for the same speed, in this case approximately 6 volts, even though we're still only running a continuous fan speed. Different meters will show different volts as we're looking at that. So now we've made a Y or Y2 call for high stage cooling. Depending on how this board is set up, this value will change based on the speed you're calling for, the torque you're calling for. Prior we were seeing approximately 8.4 volts. Now you can see we're reading between 10.5 and 10.6 on the fluke. And again, if we go back to the field piece motor, our meter, which was approximately 6 volts, we can see on that one, now we're running about 6.3, 6.4. The important thing here is you see as we step up in speed, we see that voltage going up. It's not necessarily the actual voltage that you're seeing, but the change in the voltage as you speed that motor up. So as you saw, we've confirmed that we had control voltage coming out of the circuit board at this harness. If everything checks out here and the motor still isn't running, we can remove the control wires from the motor itself, and we'll check from the brown to the yellow over here as well. As long as those voltage is showing here, we know that the input to the end bell of the motor itself is good, and at that point we'd be looking at a motor issue. So we've spoken about different speeds and that voltage climbing as the airflow on the motor goes up, speed of the motor goes up. If you're not getting any voltage at all at these control wires with this disconnected coming from the motor, that tells us that the circuit board isn't giving us an output for blower speed. At that point we're looking at a circuit board problem.